Hey everybody, this is Mr. Ainsworth, and we are going to get into a cool lesson about how to rapidly add numbers, consecutive whole numbers starting at 1. And I'm talking about like this: 1 plus 2 plus 3 plus dot 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 dot, all the way to some particular number n. What does that equal to? For example, if you want to add the numbers, the first 15 counting numbers, how would you do it? And how would you do it quickly? And I'm talking rapidly in your head. All right, and this goes all the way back in the old days, in the um, when they started developing formulas here. But there's a cool formula that can be or that was developed many years ago to add what are called the whole numbers or counting numbers starting at 1 all the way to some particular integer or whole number n. So what is the sum of 1 plus 2 all the way up to, let's say, 100? What does that equal? What is the sum of 1 plus 2 plus 3 plus all the way up to 1,000? Okay, what is that? I mean, to do it by adding two numbers at a time and summing them up two numbers at a time, that would take you a whole long time, guys. All right, and so the question is, how do you do it quickly in your head? All right, without any paper and pencil, without a calculator, because this number here, the sum of 1 to 1,000, is quite big. So how in the world do you do it? All right, so what I'm going to say to you is this: the sum of the numbers from 1 to n. All right, I'm talking about consecutive whole numbers here, starting at 1, going all the way to n, is equal to a very simple formula. You take your last number here, and which we're going to call n. You're going to multiply it by the next number, which is n plus 1 more, and simply divide that by 2. All right, that's the sum of all whole numbers from starting at 1 going to n. All right, and that's what you need to remember, okay? It's slightly different than the formula we used when we talked about Gauss, all right? But it will work when you want to find any of these sums. So let's take a look at some examples here, all right? If I wanted to figure out the sum of all whole numbers up to 15, oops, so plus all the way up here. My last number is 15, okay? And I want to add up all numbers 1 to 15. So I take 15 times the next one, 16. That's the next number here, the next integer. Okay, or I can say whole number. Okay, and then divide that by 2. So it's 15 times 16 divided by 2. So you take, I would simply take half of 16 to get 8, multiply, do a 2 by 1, 80 plus 40, 120. So it's 120. And that is as simple as it gets, okay? If you have to add up the numbers 1, 2, 3, all the way up to 25. Okay, that's simple. It's 25 times 26, divide that by 2. So divide 26 by 2 to get 13, and then take 13 times 25. So let's do that on our head. Let's see, 13 times 25. So 25 is 100 divided by 4, so I take 13 divided by 4, and that's 13 divided by 4 is 3 and a quarter. 3.25, and then you multiply by 100, so this should be 325. All right. You could check your work here if you like. 25 times 13, okay, and you get 325. All right. Now, just a couple more times, just for funsies here. 1 plus 2 plus 3, all the way up to, plus all the way up to 50. All right, this one is 50 times 51. The next one, divide that by 2. All right, let's take half of 50 to get 25. So we got to do 25 times 51. To do this in my head, I got to take 51 divided by 4 and then multiply by 100. That's the same as multiplying by 25. So 51 divided by 4 divides 12 times, the remainder 3, so 12.75. And then I multiply by 100, so I get 1275. All right, let's check it. Okay, so 50 times 51. Boom, right there. Whoa, I was off by, what am I doing here? 12. Oh, 51 divided by 4. That's, oh, what in the world did I do? Oh, I forgot to divide by 2. Got to perform the calculator, so divide that by 2. Oh, there we go. I was right. thought I was wrong, but I'm right actually. Well, that's silly. Okay, so I get 1275. All right. And it doesn't get any harder than that. The numbers just get bigger. That's all. If you have to add 1 plus 2 plus all the way up to, let's say, 100, all right, it's not any harder. You take 100 times 101, divide that by 2. So take half of 100 to get 50, and now you just multiply 50 times 101 in your head. You can do that in your head too. How do you do that? Well, you use your addition method. So 50 times 100 plus 1. That's 5,000 plus 50. All right, and you do that in my head, 5,050. And then you check. All right, so you take 100 times 101 divided by 2. Boom, 5,050. All right, and this goes back to the Gauss problem when his teacher, when he was like in, I don't know, fourth, fifth grade, asked him to count the numbers from 1 to 100. He did it in just seconds because he saw a pattern. And he figured out that the sum was 1,050. All right. And when you get creative like this and you solve things in quicker and faster ways, you become a mathematician. All right. And so this is Mr. Ainsworth. I'll see you in my next lesson. Signing off. Bye bye.